All attendees are in listen-only mode.
Welcome everyone. Thank you so much for joining our presentation today. My name is Corey Brickman, Marketing Community Manager here at Neo4j, and today I am joined by Will Lyon, our Developer Relations Engineer, and we're very excited to bring this presentation to you on an intro to Neo4j and Graph Databases. We'll go ahead and have a live Q&A session right after Will's presentation, so please feel free to submit any and all questions to the questions section of your GoToWebinar control panel, and we will get to those right at the end of the presentation. And we will also be sending you a recording as well as the slides tomorrow via email, so make sure to check our follow-up email for those special details. And with that, I will go ahead and hand it right over to Will.
Thanks, Corey, and thanks everyone for joining today. So yeah, today we're going to be talking about Neo4j and Graph Databases. So this is me. I work on the developer relations team here at Neo4j. Specifically, I work on a lot of open source integrations with Neo4j and other technologies. So you can see some of that work on our developer landing page. It's neo4j.com/developer. Also, feel free to reach out to me by email or on Twitter if you have any questions afterwards. I'm always happy to chat with folks. Here's our agenda for today. First, we're going to be talking about just the basics of what is a graph and what is a graph database. We'll jump into some use cases where graphs make sense. We'll take a look at Neo4j in detail, including the data model, the query language. We'll look at some query language examples. Then we'll go through a relational to graph example using an example data set. I'll mention some getting started resources that are out there for Neo4j, and then we'll be sure to leave time for your questions. So let's go ahead and get started. And just so that we're on the same page here, we're going to be talking a lot about graphs. So just to start this off, I want to make sure we're both thinking of the same thing here. So these are charts, and this is a graph. So with a graph, we're talking about some connected data structure with nodes and relationships. We're not talking about graphical things like scatter charts and pie charts. So really, a graph is connected data. So we have entities in the graph, we call these nodes. We have relationships that connect these nodes. So what kind of data are we talking about? Well, it could be lots of different things. We could be talking about roads that have traffic jams and that have traffic lights. We could be talking about a hotel that has rooms. Each of those rooms has some calendar of availability associated with it. And we could also be talking about social networks, so users who know other users. And one great thing about graphs is that it's very straightforward and easy to evolve our model. So we can add other users, we can add universities that they studied at, we can add where they work, and we can just evolve this model going forward and expanding on that until we end up with a very, very large network that we can draw some insight from. And if we look at companies that have made use of graphs in recent history, we end up with looking at some of the most successful companies. So let's take an example here, Google. So Google has built one of the most successful ad platforms on top of their search engine, which is based on a graph of web pages, PageRank. LinkedIn essentially has built a professional social network, which is a graph. Also PayPal has built a graph of peer-to-peer transactions, been extremely successful with that. And really we're seeing graph projects in almost every industry you can think of: finance, social networks, HR, manufacturing, healthcare, telecom, and retail. So let's take a look at some specific use cases. Before we do that, we sort of have this saying here that graphs are everywhere, because once you start thinking in terms of graphs, you sort of see graph problems everywhere. So let's look at some specific use cases now. The first one that I want to talk about is real-time recommendations. So we've all been exposed to these recommender systems on Amazon, products we might be interested in, on Netflix, movies we might be interested in watching. And so this is often based on a graph or a network of users and the products we've interacted with. And these systems can be implemented lots of different ways, but as a graph, the real benefit is being able to do those in real time. So lots of these recommender systems rely on batch processes that end up being pre-computed overnight, and so you may be serving stale recommendations. With Neo4j and graphs, you can do these computations in real time. So as an example, Walmart.com uses Neo4j for real-time recommendations. Another use case I want to talk about is master data management. So think of all of the entities and different data sources across a large organization. Bringing those together in the graph is what master data management is all about. So oftentimes having some single view of the customer across all of the different organizations in your company, things like that. Those are natural graph problems. Cisco uses Neo4j for this use case. Another really interesting use case is fraud detection. So think of fraudulent credit applications, money laundering transactions, things like that. That can very easily be modeled as a graph. And it turns out with fraud rings, oftentimes individuals are sharing pieces of their identity. So the different fraudulent credit applications might use the same social security number or phone number or address. It's very difficult to catch those without modeling that as a graph. And so this model has really taken off for real-time fraud detection. Graph-based search is another use case. So think of documents or any sort of media and keywords, tags that those documents might be about, lots of metadata associated with those. If we can put that in context when we're returning results for a search, we can provide much more relevant results for a user. And a customer example here is the Lufthansa airline. They use Neo4j to manage the digital assets for their in-flight entertainment system. Network and IT operations. So think of a data center, virtual machines running on servers, database servers, app servers, all of the different hardware that goes in your IT infrastructure. This is also a graph. And the use cases here usually revolve around finding dependency trees, figuring out, if a certain piece of my infrastructure goes down, what applications are impacted, making sure that I have proper failover, things like that. And HP is using Neo4j for this use case. And the final use case I want to talk about here is identity and access management. So being able to figure out what documents, what applications various users across the organization have rights to based on things like what departments they belong to. And this is also really a graph problem and can become very, very complex. So modeling this as a graph makes implementing these types of systems much more straightforward. So really with graph databases, we're talking about a way of representing your data. Let's compare this with traditional relational databases that take your data and fit them into tables and rows. With a graph, we're really talking about leaving the data in its context and taking advantage of the relationships among the data. So a relational database is very good for, we have a very well understood data structure that's not changing. We don't need to do lots of schema migrations. And we have very well-defined, known problems that involve discrete subsets of our data. So places where we have minimal connectivity. Contrast that with the graph database that is really good for dynamic systems where our data is changing or difficult to predict what the data might look like. Very good for dynamic requirements where the business requirements are changing. And problems where we're really deriving a lot of value from the relationships in the data. So let's take a deeper look into the data model that Neo4j and Graph Databases use. This is called the property graph data model. And the example we'll use here is of a happy couple, Anne and Dan. They both love each other. Let's see how we can represent this as a graph. Well, the entities become nodes. So we have a node for Dan, a node for Anne, and to represent this loves, we'll do that as a relationship. So we have this loves relationship between Anne and Dan. And in Neo4j, it's important to note that relationships are directed. So if we need to represent that Anne loves Dan and Dan loves Anne in return, we'll need to do that with two different directed relationships. We can also represent that they live together with a relationship. And we can also start to add properties onto these nodes. So properties are key value pairs. So we'll store the name, their birth date, things like a Twitter handle. Let's add an entity to the graph here. So we'll add a car. So we'll create a new node for this car, and we'll say that Dan owns this car. This is a Volvo, so we'll store some properties there. And we can also represent Anne driving the car. Dan is also going to be driving the car, so we can add more relationships. And we can also store properties on our relationships. So again, key value pairs on the relationships. So here we're storing dates. And there's one more component to the property graph, and that's the concept of labels. So you can think of labels as a way to define the type or the class of the entity. So we'll add person labels for our person nodes, and we'll add a car and a vehicle label to our Volvo node. If we compare this data model to sort of the English language and syntax there, we can think of the nodes as nouns, our properties on the nodes as adjectives, our relationships as verbs, and the properties on the relationships as adverbs that describe these verbs. So just a quick overview of the property graph model that we just talked about. Nodes, these are the entities in the graph. We have labels, we have key value pair properties, and similarly with relationships, we have a type, direction, and key value properties for relationships as well. So let's talk a bit about why graphs, why graphs make sense. What are the benefits of using the graph model and graph databases? And there are really three sort of high-level things here: intuitiveness, speed, and agility. So let's take a look at intuitiveness. So we like to say that graphs are whiteboard friendly. So oftentimes when we're in a meeting or brainstorming and we're trying to describe the domain for some problem, we go to a whiteboard and we draw something like this. So here we're describing the hierarchy of some organization. And this is a graph. This is how we think of the data. And where the huge benefit of intuitiveness comes into play is that with a graph database, when we go to implement this in our application, we use the exact same data model as how we think of the data. So we don't have this impedance mismatch in how we're representing the data in our database and how we're thinking about the data. This is a huge benefit. Speed is another benefit of using graphs. What does this mean? Well, let's take a look at here a simple social network relationship. So we have Andreas who knows some of his friends. And with a graph model, we can represent that directly with just a single relationship here. With the relational model, however, we need to use a join table here to represent this. And if we're traversing this in a graph, we have this concept of index-free adjacency. So we can traverse from one node to any other node that it's connected to without doing an index lookup. So this is very, very performant. This gives us constant time traversal, so the performance profile of our queries does not change with the data set as long as we have index-free adjacency. And this enables us to traverse the graph very, very quickly. If you have an application where you're doing lots and lots of joins in SQL and relational databases, this is oftentimes not going to be very performant. But with Neo4j, we find that you can often go from queries that take minutes or seconds in relational databases down to milliseconds in Neo4j. And the third benefit I want to talk about here is agility. And there are really two components to agility here. The first is that the graphs are a naturally adaptive model. So we saw sort of at the beginning how we can change and add to our data model without doing things like schema migrations. It's very, very straightforward. The other piece of this is a query language that's designed for graphs, designed for connectedness. And this query language is Cypher. So you can think of Cypher as SQL for graphs. Let's just take a very brief look at some Cypher examples here. So going back to our Anne loves Dan example, Cypher is all about pattern matching. And so we use these sort of ASCII art patterns to define nodes and relationships. So nodes are represented within parentheses. Labels come at the beginning of that pattern. We represent key value pair properties inside curly braces, and relationships are represented within brackets. So here we have this create statement with a graph pattern. So if we were to execute this against our database, we would create two nodes, one for Anne, one for Dan, and connect them with this loves relationship. So that was a create query. If we're searching for some data in our database, we're going to use a match. You can think of match as similar to a select in SQL. And we use the exact same pattern here. So here we're searching for a path where Anne is Facebook friends with Dan. And it's important to note, as we mentioned earlier, that all relationships in Neo4j have a direction, but with Facebook friends, there isn't really directionality there. You're either both friends or you're not. So when we query the graph, we don't need to specify a direction in the relationship. So we can leave that piece off when we're querying. Let's compare Cypher with SQL. So here's a SQL statement that one of our customers sent us. So this SQL query is looking at an organization and asking for a certain individual, who reports to that individual, take the count and go 3 levels deep. And here's the equivalent query using Cypher. So as you can see, the Cypher statement is much more concise. We have this nice pattern matching. And so when we're using Cypher in graphs, we end up spending a lot less time writing and maintaining these very complex SQL queries. This is much easier to read and much more intuitive. Cypher was recently open sourced as part of the Open Cypher project. So Cypher is now available for many different vendors to implement. So we'll really start to see Cypher spread across different vendors and really become SQL for graphs, not just on Neo4j. So let's take a step back here and see what we've talked about. So the main components of Neo4j and graph databases are the property graph data model, made up of nodes and relationships. We talked about this concept of native graph processing. That's being able to traverse the graph very, very efficiently using index-free adjacency. And we talked a bit about Cypher and the open Cypher query language. Let's look at some of the other product features of Neo4j. So one is native graph storage. This just means that we're storing the data as a graph, and this is what enables us to have native graph processing, so that when we're querying the graph, we can do millions of traversals per second per core on your machine in real time. We talked about this whiteboard-friendly data model, so that we're storing the data as a graph. We're using the data model when we implement our application, the same model that we're using to think about our data. One thing that I didn't mention yet is that unlike other NoSQL databases, Neo4j has fully ACID transactions. We talked about the Cypher query language. Neo4j is also scalable with high availability. We have support for server clustering, which we'll look at a bit more in detail in a moment. There are also some built-in ETL tools for data import. We'll look at some of these also. And we also have drivers and integration with other languages and frameworks. This is the piece that I work on specifically, so we'll see some examples of this later on as well. So we talked about the data model, we talked about Cypher. Let's talk about how we actually use Neo4j. So the basic idea here for building some application is creating our data model, loading the data, and then querying the data. That's sort of the core functionality of a database, right? So let's take an example here of how we can query our data. This is often done using the Neo4j browser. So once you download Neo4j and start the server, you can connect to it through the Neo4j browser, which just runs in the web browser. Let's take a look at this here. So here's the Neo4j browser. This is just connected to a local instance on my machine here. And I have a data set here about US Congress. So this data has bills, legislators, the states they represent, the committees they serve on, things like that. So let's just do a really simple query here and just get 25 nodes somewhat at random here. So you can see Cypher query goes in here, and we visualize our results below. So you can think of this as kind of a workbench for Neo4j. Let's jump back to our slides here. So the browser is great for querying and exploring our data, but really what we want to do is build some application that uses Neo4j. So we typically interact with Neo4j through one of the many different language drivers that we have. So we have drivers in JavaScript, Java, Ruby, .NET, Python, PHP, even some of the newer languages like Haskell and Go. We also have drivers that support that. You can also write native Java code that can be embedded in the Neo4j server. This is another common approach. So what does Neo4j look like sort of from an architectural vantage point? So here we're showing Neo4j running as a 3-node cluster. Their application is connecting to Neo4j works well with other databases. So we may have relational or other NoSQL databases that we're connecting to, syncing data back and forth. And here our data science is also connecting directly to Neo4j to do some analytics queries. So this is a common approach. Let's take a look at sort of how a relational developer, someone that comes from the SQL world, would approach Neo4j and graphs. So if you've written a lot of SQL, there are some things that are a bit painful that you're probably familiar with. So things like modeling and storing relationships, writing lots of joins, and seeing that the performance degrade when you do that, and maintaining these long SQL queries that have lots and lots of joins and complexity. That's no fun. And so really, when you transfer to a graph model, you'll very quickly see that it's very easy to model and store relationships. You don't have this degradation of performance when you start doing graph traversals. Cypher queries are shorter and much more maintainable than SQL. So let's look at an example. So here's an entity relationship, or ER diagram, that any relational developer should be familiar with. And this looks a bit complex at first. It's sort of difficult to figure exactly what's going on here. This is the Northwind data set. So this is sort of the canonical relational example. This ships with MySQL and SQL Server. And what we're going to do is translate Northwind to the graph model. And we'll end up with something like this. So we have nodes for the entities in our data model, things like employees that report to other employees. We have orders that include certain products. We know the category of those products. We also have the supplier for the products, things like this. So looking at this as a graph model seems much more intuitive. This is how I at least naturally think about this data. So really, relational Northwind is really better represented as a graph than a relational model. So how can we convert this data set from the relational model to a graph? So starting from the ER diagram, the first thing we do is identify the foreign keys. So these foreign keys are pointing to rows in other tables, and we can just drop these. We don't need these in the graph model. Instead, what we'll do is we'll name some of our relationships now. So we have order details of some product as an example. The next thing we do is find the join tables. So here we have an order details join table, and we have an employee territories join table that's joining employees to the territories that they're responsible for. And our simple join tables, they just become relationships. So here we just have a employee represents some territory relationship. And join tables with attributes become relationships with properties. So we have an order that includes some product, and we're storing the unit price, quantity, and any discount that we have for that product as a property on that relationship. So let's take just a subset of this data set for orders, products, categories, suppliers, and employees. We'll take the graph model of this. So orders that include products, employees that have sold an order, the category and supplier of the product. Let's just take this piece and see how we can query this as a graph using OpenCypher. So just jumping back to a simple Cypher example here. We'll look at relationships with this reports to type, so representing our organizational hierarchy. And the first query we want to run is who people report to. So who is your boss? So we do this with a simple match statement specifying the label of the node that we're looking for, so employee, and we want to find employees with this reports to relationship and then return all the results that we find. And what we get is this graph that looks like this. So here we can see the organizational hierarchy of our organization. Alternatively, we can return this data as a table. So here we'll grab the employee ID and first name for both the manager and the employee. And instead of returning nodes and relationships, we're just going to return the properties. And that renders as a table here. So we can see the employees that report to Andrew, the employees that report to Stephen, and so on. We can look at for a specific employee. So here we want to know, okay, who does Robert report to? And we can see that Robert reports to Stephen. Let's dig in a little bit deeper and let's look at Robert's reporting chain. So here you'll notice in this reports to relationship, we're adding an asterisk. What this means is that instead of just matching on one relationship, now we want to go an arbitrary number of relationships deep. So here we'll get the whole chain. And here we can see that Robert reports to Stephen and that Stephen reports to Andrew. So who's the big boss? So what this query is saying is find me an employee who has no outgoing reports to relationship, right? So who's the big boss here? And if we run this, we can see that Andrew is our big boss. Here's a query that's a bit more interesting. So we'll start at some product, in this case, chocolate, and we'll traverse out along the incoming includes relationship to find orders that contain this product. Then we'll traverse out to see the employees who sold this order that contained chocolate. And then we'll traverse out from those employee nodes to other employees who have sold other orders. And we'll see what other products are included in those orders. Then we'll do an aggregate here, counting the distinct number of orders that we're seeing, and we'll return the employee and the other product that they're selling. So let's look at the results here. So this is basically showing us, okay, for employees who have sold this product, chocolate, what other products are they selling with that most frequently? Okay, so that's an example of how we can query the Northwind graph. Let's take a step back and look at how we can load our data into Neo4j in the first place. And one of the ways we can do that is using CSV format as an intermediate format for going from relational databases to graphs. So most relational databases and even other NoSQL databases have good functionality for exporting to CSV format. So a CSV file for Northwind might look something like this. So here we're looking at a CSV for orders. We have lots of CSV files for employees, customers, products as well. So there's sort of three steps here for importing our data. The first, we want to import our nodes. Then we want to create indexes to make sure that querying will be performant. And then we create our relationships. So we talked about some ETL tools that are built in to Cypher and Neo4j. One of these is the load CSV tool. This is built into the Cypher query language. So this allows us to load a CSV file from a remote URL or a local file, and then we can just use Cypher to define the patterns that we want to create from the data in that CSV. So in this case, we're loading our customer's CSV, and we're creating customer nodes and storing properties on the customer, and then we're doing the same thing for products. If you'd like to work through the whole Northwind example here for importing and querying some of the data, you can do that in Neo4j with this in-browser guide just by typing :play Northwind graph. So let's take a look at this. So in this place here where we insert our queries, we just type play Northwind graph, and we get this in-browser guide that we can click through that describes the domain and also has the Cypher queries for importing and querying this set. So just wanted to mention that that ships along with Neo4j as a great way to sort of move through this example. So we looked at load CSV. Load CSV is good for loading kind of what I would describe as sort of intermediate size data sets. So CSV files of up to maybe a few million rows. Beyond that, you might want to use the Neo4j import command line tool. So this is much more performant for doing initial data loads where you have 10 million rows and beyond. As a performance example, we loaded all of DBpedia, which has over 4 million entities and their relationships. This loads on a laptop in about 100 seconds. So that's about 100 million rows per second, something like that. So let's take a deeper dive here at powering an application using Neo4j. So let's just take a really simple app here. We want to query this Northwind, this Northwind data set and report employee relationships. So these reports to relationships. So let's look at the Python code that we can use to do that. So this is using Py2Neo, which is the Python driver for Neo4j. And so the first thing we need to do is connect to the graph. So we do that just by specifying the protocol, username, password, and the host and port for Neo4j. Then we define some Cypher query. So here this is iterating through all of the employees with this reports to relationship and returning the data from that. So we execute this Cypher query, and then we iterate through the results, building up the HTML that we want to display. And that's basically the core functionality of just querying the graph using Python and to power this really simple application. So I just want to mention a few resources that are out there for getting started with Neo4j. The first is to download Neo4j itself. So Neo4j is open source. You can download and get started with Neo4j today at neo4j.com. If you don't want to download Neo4j and instead just get started through the web browser, we've built this network.graphdemos.com site. So with this, you can sign in using Twitter, and we'll automatically pull in some of your social network data from Twitter and store that in a Neo4j instance that you can connect to through the browser to start exploring some of your own data right away. So this is a great alternative if you just want to get started with Neo4j without downloading and installing it. The developer landing page, so neo4j.com/developer, is a great place to look for example code for using any of our drivers. We also have some sample Cypher queries for some different use cases. And there are lots of other ways to interact with the community. We have a public Slack channel that lots of members use to interact. A lot of the Neo4j folks are on this channel, so it's a great way to get feedback on a data model or ask for help with some problem you're stuck on. Stack Overflow is another great place to ask questions around data modeling and Cypher Neo4j issues. We also have lots of meetups and trainings throughout the world. Those are on neo4j.com/events. Probably find something coming up in your area soon. There's also the O'Reilly Graph Databases book. This was recently updated for the 2nd edition, and you can download this for free on graphdatabases.com. We also have these interactive documents called graph gists, and this is all community contributed content. And this is a great way to discover interesting use cases. It's really amazing what people are using Neo4j with. So it's a great way to both discover and also share your use case and sample data by embedding Neo4j in an HTML document. So that's all I have. Thank you for attending. Again, feel free to reach out to me by email if you have any questions to follow up with later. But I think we have time now to take some questions live here.
Excellent. Thank you so much for that presentation, Will. And that is correct. We will go ahead and begin taking your questions. So thank you to everyone who's already submitted those. You can keep submitting those through the questions panel, and I'll go ahead and start asking them. The first question is about relationship detection, and it is, are you able to detect non-obvious relationships using a graph database?
Yeah, that's a good question. So there's this concept of an implicit relationship, right? So there may be a case where, let's take our legislative data set as an example here. So here we have a sponsored by relationship. So we can see here Senator Brown has sponsored lots of these bills here, and if we traverse out from one of these bills, we can see other legislators that have sponsored the same bill. So really, there's an implicit relationship from Senator Brown to Senator Daines here that they have sort of co-sponsored. They've both sponsored this bill, and you see this in retail for recommendations. You see this in social networks. In graph theory, this is called a triadic closure. So identifying triads in the graph. So really, this is a great way to identify implicit relationships where we know that Senator Brown and Senator Daines have worked together because they both sponsored this bill. So identifying implicit relationships is really fairly straightforward. And that's sort of what I think about when I think of hidden relationships.
All right, thank you. Our next question is about bidirectional relationships. It says, is there a shortcut that allows you to define a bidirectional love relationship, as per the example, rather than having to define two separate unidirectional love relationships?
Yeah, that's a good question. So as I mentioned, all relationships in Neo4j are directed. So when we create the relationship, we need to specify some direction here. However, we don't need to specify a direction when we query. So the example here that I had was this Facebook friends relationship. That's non-directed. So then when we query, we don't have to specify a relationship, and we can find that in either direction. Even though that when we created the relationship, we did specify a direction. So really the pattern there is when you create the data, specify a direction. When you query, don't specify it, and you'll find it anyway.
Excellent. Our next question is regarding a Cypher command. It says, I'm interested to know how the Cypher command to give a node two labels. So they understand how to assign a node a single label, but is it possible to give a node two labels?
Yeah, absolutely. So nodes can have multiple labels. So we can do something like this. So let's create a person with the name Will, and then let's go find me here. So here I am. So I just have one label and this person. So let's add another label, and the syntax to do that is using set. So we just say set me and add another label here. So we'll add, I don't know, human, and return that. And so now you can see this, I now have the human and person label. So the syntax to do that is just this set. So first, if you're matching, match on some pattern and bind to some alias, and then set with the alias and then a colon for the other label that you'd like to add. And we could have done this with the create too. So here, when we created this, we could have just appended a set like that. One resource I didn't mention is the Cypher ref card, which is available in the docs. And this is a great resource as a reference for just discovering Cypher commands, syntax, and examples. So this is sort of the first resource that I would look for when using Cypher. I still use this document pretty much every day for referencing Cypher things, so that's a great place to start.
Great, thank you. The next question I have is it possible to use check constraints on certain node properties? For example, integer properties can only have values in a certain range.
Yeah, so there are some constraints that you can impose on your data model. They're fairly limited though. So there is a uniqueness constraint. So we can define that a certain property has to be unique, so that if we try to create another node that has the same value as another node where we have a uniqueness constraint, that transaction will be rolled back. The other type of constraint that we have is a property existence constraint. We can assert that a node of a certain label must have a certain property in order for that node to be created, and the same on a relationship based on a relationship type. Those are the two schema level constraints that you can impose now. For more specific type of constraints, those would have to be implemented at the application layer or as a transaction hook in Neo4j. There's a section here in the manual that describes how to implement transaction hooks somewhere in here. So if you just search the manual for that, you can see how to build one of those. Basically, it's Java code that you then deploy to the server that's called before any transaction is committed. So you can inspect the transaction and verify that the constraints hold true for the transaction before committing it.
All right. Our next question is, what is the maximum number of nodes and relationships that Neo4j can support?
Yeah, so right now there is a maximum number of nodes and relationships. Again, it's specified somewhere in the manual here. I think it is 34 billion nodes, 34 billion relationships, something like that. 64 billion properties. So that is the maximum. That is, yeah, here we go. So about 34 billion nodes, 34 billion relationships, about 68 billion properties, depending on the size. So that physical limit is imposed by the address spacing in the way that we index the data. Oftentimes, we find that is for the use cases that our customers have, that is a reasonable limit, and we have many customers with graphs in the size of tens to hundreds of millions of nodes, and that's sort of the typical real world maximums that you'll see. But we do have a few users with graphs in the billions of nodes and relationships as well.
All right. Our next question is the Groovy language supported?
Yeah, that's a good question. So Groovy is a JVM language. I believe there is a Groovy driver out there. I'm not sure about that, but if you check in our Neo4j contrib repo, so this is where some of our open source projects live. I probably spelled Groovy wrong there, but this is a good place to search. It's two V's, but yeah, I mean, really, we have support across lots of JVM languages.
All right, thank you. And our next question is more of a statement, actually. This person says they're interested to taking the Neo4j certification, and could you please provide some references?
Sure. So the Neo4j certification is a program that we recently launched. Basically, there are 80 questions, and as long as you get 80% correct within 60 minutes, you become a Neo4j certified developer. These are the subjects of the certification. So some of the things we talked about today, the property graph model, Cypher, data modeling. There are also things on deployment and using Neo4j in production. As a study guide, references that I would recommend for preparing for the certification. The first one is our developer pages. So on the developer pages, I mentioned this earlier, that we have sample code for connecting from lots of different drivers. We have some Cypher examples for different use cases. But we also have lots of information about using Neo4j in production, tools and integrations, data modeling guides. So this is a great place to go through these tutorials to prepare for the certification. Also, certainly the Graph Databases books that you can download for free. We also have online training courses that you can get started with right away. This is a great way, especially for the Neo4j in production things that might not be covered in depth elsewhere. Also, we do in-person trainings. So if you look on neo4j.com neo4j.org/events. You can find upcoming trainings in your area. Like I said, we have these trainings all over. I know I'm going to be traveling to Denver soon, so I'll be doing a few trainings there. Yeah, so those are sort of the materials that you can use to prepare for the certification. Of course, the Neo4j manual, the reference manual, this is sort of the the source that contains all of this information. So reading through the manual, you should be able to sort of absorb all of that. You'll have everything you need to know to pass the certification.
All right. We have just under 5 minutes left, so we'll go ahead and begin taking our last few questions now. This next one says, I need to migrate data from a SQL database. Is there any other way besides CSV?
Yeah, so as I mentioned earlier, CSV is sort of the standard approach that we recommend, just because every database can dump to CSV, and we have nice tooling with the load CSV and the Neo4j import tool around importing from CSV. If you don't want to use that approach, there are a couple of other approaches. So one way is if you want streaming data updated in real time, is you could look at implementing something that tails the transaction log for your database and implement the transaction hook or something like that that converts the update to a Cypher statement and shoot that over to Neo4j. There are a couple of, I guess, what I would call experimental projects out there. One is this Neo4j fire hose that Stefan, one of our field engineers, wrote. Basically, what this does is it allows you to connect to a relational database using JDBC, and it will stream the results of a SQL statement or the rows of an entire table, stream those in CSV format so that you can then use a load CSV Cypher command to import the data without actually having to dump it to CSV. So this is CSV Firehose, and I'll make sure we send out a link to all these projects in the email that goes out. So that's one approach. There's another project that I probably will not be able to find immediately, but this is a project that one of my colleagues wrote that inspects the schema of a relational database. Here we go. So the way this works is it inspects the schema of a relational database, and based on some transformation rules, creates a property graph model from that, and then uses the highly performant Neo4j import batch import tool that I mentioned to do an initial import into a Neo4j database. So again, this is kind of a experimental project that's out there. I've used it. It works. So that's certainly another approach as well. But in general, unless you have a specific reason for not wanting to dump to CSV and use one of those approaches, I would stick with that.
All right, thank you so much. We will take one more question now that we are at the top of the hour, and for the rest of your questions, we'll go ahead and respond back to you personally via email, and if you come up with any later today, you can feel free to email either Will or you can email webinar@neotechnology.com, and we'll make sure to get back to you. The last question is, I'm working on a multimodal routing application. We're having various challenges with our data. Some of the data is static and some is in real time, different countries, different standards and data models, etc. How can Neo4j help me with this data challenge?
That's interesting. That's something I think where I would have to sort of look at an example of the data model and maybe your specific infrastructure. So I'm not really going to have a good answer for that other than, that sounds like an interesting problem and I would like to help you with that. So please shoot me an email and we can definitely dive into that offline.
All right. Well, thank you so much, Will, for that presentation, for taking all of those questions, and thank you everyone so much for joining us today. Go ahead and look out for our follow-up email where we'll be sending you the recording of today's session, as well as the slides and the links that Will has mentioned. Thank you so much, and we hope we'll see you on another webinar soon. Thank you so much.